Hi ladies, this is Mrs. Blaufuss. This is lesson 8.1, and in this lesson we're modeling inverse and joint variation. So think back to last semester when we did direct variation. Direct variation, we had this equation y equals a times x, where a is our constant of variation and x is an independent variable, y is a dependent variable. Now the inverse here, what we're doing is we're saying a times x. The inverse operation of multiplication is division. So when we look at this inverse variation, we have y equals, instead of multiplying by x, we're dividing by x, where our constant of variation is a. Now in this inverse variation, a cannot equal 0, because if a equals 0, then it's 0 divided by whatever x is, and so your y will always be 0. So in an inverse variation relationship, we are not going to have a constant of variation that is equal to 0. Now a joint variation is like direct variation, but instead of varying with one quantity, it's going to vary directly with the product of two or more quantities. So in joint variation, the quantity varies directly with the product of two or more other quantities. And remember what product means? That means multiplication. So in this key concept, you've got your inverse variation, y equals a divided by x, where the constant of variation is a. So when we have this, we read it as y varies inversely with x. All right, let's look at a couple examples. So if you have a given equation, y divided by 9 equals x, and we want to rewrite this, we're going to rewrite these equations as y equals. So y equals 9 times x. Now, what kind of variation is this? If we're multiplying 9 by x, where 9 would be our a value, our constant, we have either direct variation, inverse variation, or neither. Well, direct variation is y equals ax. Inverse variation is y equals a divided by x. And neither is you're doing some other operation. You're not dividing by x, you're not multiplying by x, maybe you're adding or subtracting or something else. So in this first example, this is an example of direct variation. Here, if we rewrite our equation, we have y equals 3 divided by x. So we're taking our constant, which is 3, and we're dividing by x. This is an inverse relationship. So try the next 3 examples on your own, and you can unpause for the solution. So pause while you work, rewrite the equation, unpause for the solution. So the first example, because we're adding x, it's neither. We're not multiplying, we're not dividing by x, we're adding. Number 2, if we rewrite it, we get y equals 5 divided by x. That's an inverse relationship. And number 3, if we rewrite the equation to have y equals, we have y equals 2.6 times x, which is direct variation. All right, now in this next example, we're writing in an inverse variation equation. So again, inverse is y equals a constant over our independent variable. So if the variables x and y vary inversely and y equals 3, so 3 equals some constant over our x, which is 6. So y equals 3, x equals 6. So we're looking for, first, we're looking for our constant. So we're going to set this up into steps. So step 1, find a, which is our constant. And we can do that by multiplying x and y together. So a equals 18. The second step is to write an equation that relates x and y. So our second step is an equation. So y equals our constant of variation divided by x. And then lastly, our third step is to find y when x equals -9. So we don't know what y is, but we do know our constant is 18, and we do know our x value is -9. So we need to solve for y. Y equals -2. So first solve for a, but the question really is to write an equation that relates x and y. So you have your x and your y in your equation. And then the third step is to find y when x equals -9. Try this next example on your own. So you'll need to first find a, then write an equation, then solve for y. So pause while you work, and you can unpause for the solution. When you solve for a, you get a is equal to 22, again using y equals a over x. Solve for a, write your equation, y equals 22 over x, and lastly, solve for y. All right, now in this next example, we're going to look at this data table. Now we have a bunch of x's and y's, or in this case, they're m's and n's. So we need to determine whether they show inverse variation, and if they do, we're going to write a model. So in order for this whole table to show an inverse variation, the constant has to remain constant. So in this example, our inverse function is y equals a divided by x. So in this example, we have n equals equals a over m, whatever our constant is. So we need to find our constant. So in this first example, in this first data set, we'll say, okay, we'll say 45 equals some constant over 5. Is that the same as this constant and this constant? Is it the same? Is the constant the same for all of these? Okay, so in order to see whether or not that's true, we need to find the constant in every scenario. So in the first one, our constant is 225. 45 times 5, our a value is 225. So is that always true? Is 225 divided by 10 equal to 22.5? And is 225 divided by 15 equal to 15? And is 225 divided by 20 equal to 11.25? And then lastly, is 225 divided by 25 equal to 9? Well, yes in this case. Yes, 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 and yes. So if you do the math, 225, our constant, divided by our m, our independent variable, is always equal to our dependent variable in this data set. So therefore, a equals 225. Now, if we were writing a model for this, so we don't know, we're looking somewhere in the future, we're looking for some other m value, we would be able to find n. So given some independent value for m, for example, m is 45, we can find n because we know that n is equal to our constant of variation divided by m. So if m is 45, then n equals 225 divided by 45, which is 5. Okay, so when you're looking at a table of data, you have to make sure that your constant actually remains constant. In this case, it does. All right, try this next example on your own. Please pause the video while you work, and you can unpause for the solution. Remember, you're looking to see whether or not it shows inverse variation. So you need to find whether or not you have a constant. If you do, what is the constant? And then write a model. In this example, yes, we do have an inverse variation because any time we divide 36 by the x value, we get the y value that's on our table. So our constant of variation is 36. So to write a model that gives y as a function of x, we need two variables. We need y and x, and then we need our constant of variation, which is 36 in this example. All right, the next part of this lesson is joint variation, and joint variation is like direct variation. So remember, direct variation is y equals ax. That's direct variation. And the difference here is that instead of just having a times x, we have a times x times y. So it varies jointly with x and y, the product of two or more other quantities. So we don't just have a times x, we have a times x times y. So let's look at a couple examples here. The variable z varies jointly, so z equals some constant times x times y. So we're going to use joint variation here. Now it tells us what z equals. So negative 84 equals some constant, which we don't know. And it tells us our y value and our x value. So we know that negative 84 equals negative 12a. And so in order to solve for a, we divide both sides by negative 12, and we get an a value of 7. Now that's not the question. It doesn't say solve for a, but this is our first step. First step, solve for our constant. Now our second step is to write a model. So in our model, we're going to replace a with our constant. So z equals 7 times xy. And then lastly, our third step is solve for z. So we know that z equals 7 and x equals 5 and y equals 2. So z equals 70. So here's our model, z equals 7xy, and then when we find z, we replace x and y with the given values. All right, let's try writing some of these relationships. Now, some of these are a little bit wordy, so we need to think about what each of these means. So m varies jointly. Varies jointly is going to give you your equal sign with some constant and n, p, and q. So m equals a times n times p times q. And the second one, r, varies inversely. That means division. Jointly means multiplication. So r varies inversely with s. So r equals some constant divided by s. Again, here we have inversely. X varies inversely. So that's a divided by the cube of y. So that's y to the third power. So a over y cubed. Right, and then the last couple, k varies. So we'll have k equals jointly, which means a times x and y, and inversely, which means division, with m. So when we write our model, we have k equals a x, y divided by m. And then our last example, t varies. So t equals directly, which means a times u, and inversely, which means division, with w. So t equals a times u divided by w. So now try these next two on your own. You can pause the video while you work, and then you can unpause for the solution. So remember, you have to write an equation and then find z. Right, so before you write your equation, you have to solve for a. Then you can write an equation relating z, x, and y. So z equals 11xy. And then lastly, when x is 6 and y is 3, z is 198. And then for the second example, write an equation for the relationship x varies jointly with y and z, and inversely with the square of t. So inversely means division, jointly means multiplication. So it's a times y and z divided by t squared. All right, so that's all for this lesson. So please jot down any questions you have, and we can address them in class. Thank you.